Hello guys, welcome back. In the previous video, we have understood the logic just to print the elements of the array in reverse. But now here, what we'll be doing is, we'll be directly reversing an array. So if you observe over here, so this is our original array. So if you try to reverse an array, the element which is at the last index 6, that is moving to the index 0. Similarly, 4 is moving to the index 1. Similarly, 1 is moving to the index 2 and so on. So what you are supposed to do? Let's say imagine the same situation in your respective classroom. So there are a couple of people in the classroom. So what you want to do? You want to take the first person and move that respective person to the last person place. So means here what exactly is happening? 17 came to this, 4, next 1, next 6, 3, 9 as well as 2. So if you want to work in this respective way, how will this respectively work? So what you are supposed to exactly do? So what is the logic basically over here? You take the value 2 and directly go and put it at the last. But if you keep in this respective way, where is the last value? 17. We lost it, right? So what do you do? So before moving that, take that respective value 17. So consider the value 17. So we store this respective value in some variable called temporary. Okay, in this some temporary variable, the value 17 we have. So now what we will be doing? You will be making this respective value 0 into the last respective place. Done. So now what you need to do? In the index 0, you need to keep this temporary value. Okay, basically, I think what you can say, this is the logic of swapping. All right, so this is fine. So after this, what you are supposed to do? The index 0 as well as the index 6 are completely done. Now you increase. So if you increase the value of I by 1, the same respective thing you are supposed to also decrease from last. Means the same value 9 as well as 4 need to be swapped. So let's go swap it. So first, what do? Maybe either the way you just go take the value 9, you store in temporary, or the value 4 in temporary also it works. Let's say now taking the value 4 over here, let's put it over there and now take the value 9 and store it over here. Okay, step number 2 is done. Let's go now over this place. Now what you'll be doing? Again the same. Let's go take the value 3. Now the value 1. So 1 moves to the respective place where 3 is there. And now let's take the value 3, which you have stored in temporary. So again back to that respective original position. Now again you increase the value of 5. So now if you increase, it is the fourth position from the start and it is also the fourth position from the end. So now what happens? 6 itself is swapped. Okay, doesn't matter even though you store that in temporary and the same value is being again stored over there. So again I is increased. If again you increase the value of I, now what happens? So now exactly if you see, the values in your respective array are now swapped. So you see the array is now reversed. But again if you try to do, means what happens? This value 3 and this value 1 are swapped. Means what happens? Again it goes back to the original position that we don't want. So in this respect to case, what you are supposed to do? You start and you need to traverse only until the half of the array. So means exactly until the value where your size by 2. So means the size is 7. What is 7 by 2? 7 by 2 is basically 3. You need to go exactly until the value 3. So this is how the logic works. So means what you'll be doing over here? You go take a loop int I to 0. So what is your endpoint? You go exactly until the half. So I less than size by 2, I increased by 1. So now what you will be doing? So you need to take the first respective element. So let's just go take this. All right. So now you need to take the first element means int temporary equals to ARR of 0. This need to be swapped with what? ARR of 0. In this respect to thing, I want to get the last means ARR of size minus 1. This is what you get. Okay. So this is what you get. Next, what you need to do in the last place, ARR of size minus 1, we need to keep the first value. Where is the first value stored? In the place of temporary. Okay, but every time you will not be doing with the first and last, right? Let's say for the second time, what you'll be doing in the place of index 1, then here also it would be plus 1. As you increased by 1, what you are supposed to do? You're also supposed to decrease it by 1. Again, you're also supposed to decrease it by 1. Let's say if you are increasing it by 2, means in the third place, you need to keep the last third value. So means every time if you are increasing something, the same also need to be decreased. Means if I say it is I, so if you do some incrementation of I, you need to decrement in terms of I. Maybe instead writing 0 plus I, directly we can keep it to I. So this is how it works. So let's go to the online compiler. Let's try to reverse an array and check it out. So this is a normal logic just to print it in reverse. All right, let's copy this. So now what we'll be doing, let's say just go take for int I equals 0, I less than size by 2, I increased by 1. All right, so once this is done, let's go take temporary value AR of I. In A of I, what you'll be doing? So let's keep the value of size minus I minus 1. So A of I equals size minus 1 minus I, and of course size minus 1 minus I, you keep the value of the temporary. So once this is done, then what is the purpose to traverse from last? So we'll start directly from the index 0, we go until the size. So less than size, and every time you increase the value of I by 1. So even though now if I just take and run, the output should be in the reverse order. So this is how you reverse an array. So what is the time complexity? If the size is 100, you are only iterating 50 times. So if you iterate 100 times, what happens? Again, the array come back to its original position. So that's the reason we are supposed to do only size by 2. So this is the logic to reverse an array. That is all for this video. Thanks for watching. See you guys in the next one.